Good morning, sir.
Morning, sir.
Okay, good morning, everyone. I hope you can hear me clearly and can see the screen also clearly.
Sir, good morning, sir. It's clear.
Very good morning. Thank you so much. Okay, so a very quick recap on what we did yesterday. We saw that we need to keep things in control. In other words, prevent a fire and explosion on board, especially tankers of oil, gas, and chemical, because they will be always having some hazardous gas. Hazardous from the point of view with regard to fire and explosion. Okay, a flammable gas, if you want to put it there. And one of those things that are going to help prevent that from happening is that certain electrical equipment, whenever it is working, will be working with a certain temperature. Okay, whenever we are doing rounds in our engine room, we are always touching the motors that are running, no, to see whether they are running extra hot or the normal heat. Heat will be there because current is flowing through that. Okay, so based on that, okay, the temperature of that particular equipment that is running, certain equipment must be placed in these particular dangerous zones, hazardous zones, or flammable zones. Okay, and such equipment will be given a certain rating. But first and foremost, we saw what are those temperature classes. And yesterday we studied this particular table, and I gave you a rough idea how to try and memorize. As I said, disregard the first column. You have to memorize the middle column over here. Okay. And these two are very easy to think. Once you memorize this, this is the only difficult part of you memorizing these figures. Once you memorize this, or at least for your examination purposes, you don't really need to have it when you're working on board the ship. Yes, if you can look at it at that time also, there's no harm. But as far as on board, as far as your examination is concerned, because they ask you to decipher certain things, okay, and I will show you later on in a video also. Okay, the examiner will give you something, okay, and you will have to expand what are those, the EXIA, T6, something, something, so on and so forth. Okay, and as I said, if you cannot answer that question, then this being a safety related issue, they will possibly fail. Okay, so this one you have to some or the other learn it. This one, as I said, greater the T number, lower the thing. So the T number starts with T1 and ends with T6. So you start putting 1 right at the top and 6 right at the bottom. Then T1 followed by T2. T2 has 4, A, B, C, D. Then T3, T3 has 3, A, B, C. Then T4, T4, A has only 1. Okay, and then T5 and then T6. Okay, and as far as this column is concerned, as I said, normally you bring this across and put the greater to sign. Okay, and the second figure over here, you bring this across and put the less than or equal to sign. Okay, so another thing that I wanted to draw your attention to was T2, T3, T4, T5, and T6. Okay, T2 is taking this one from here. T3 is taking T2 from here. T4 is taking T3 from here. T5 is taking T4 from here, and T6 is taking T5 from here. Okay, so it is quite easy to memorize this particular thing. Otherwise, just take this across, put the greater to sign, and the second figure, bring the previous one down, put the less than or equal to sign. Very easy. Okay. Then we saw whatever the electrical equipment that requires to be placed in that hazardous region will be explosion proof rated. So you will be having the letters EX preceding that particular one. EX being explosion proof. Okay, and we saw the various type of explosion proof rated equipment. There are 9 of them. As I said, in the orals, they will ask you what are the types of explosion proof rating that there are. So you'll have to mention all the 9, of which, as I said, cross questions are normally asked on the first 3. Not to say that they cannot ask you with regard to the rest, but most of them, because these are mostly found on the rest, yes, we will discuss it as and when. And accordingly, depending on which particular ship you are, you will be cross-questioned. Most of these will not be used, okay? But we will see that so that you are not left stranded in case a cross-question is asked. We also did, we'll not go through this table because not really required. We saw what was EXD, the very first one, which is flame-proof enclosure. So such an equipment will be given this rating is provided they comply with 3 conditions. And those 3 conditions is that in case there is an explosion, an internal explosion, there should be no damage visible. We saw that video yesterday. They created an explosion inside. Okay, because they had that window and you could see that explosion, you knew that there was an explosion inside. Suppose there was no window and an explosion took place. You should be able to see that particular equipment as is, like as if nothing had happened. Okay? So no cracks in the casing and all that. Point number 2, enclosure should prevent heat and gases from escaping into the outside of the enclosure. So as I said that 2C would be that particular type for that particular motor that is located in that hazardous region. Okay, whereby the gap, the C indicating that the gap is less than 0.5 mm. So that whenever that explosion takes place, by the time that pressure and energy escapes into the hazardous atmosphere outside, it would have cooled sufficiently. And we saw that the minimum ignition temperature level is not reached. You have to have a minimum ignition level, no? The temperature, the ignition source that is going to be supplied in order to complete that fire triangle, sufficient amount of energy also is required. So by the time, in this case, that energy finally comes out into that particular hazardous region, it has lost quite a bit of energy and therefore will not be sufficient in order to create a fire and explosion. And point 3, external surface temperature should not increase greater than the ignition temperature of the gas that is surrounding it. Okay, we saw that particular table just now again. Okay, so if all these 3 parameters are met, then yes, this particular equipment can be given an EXD rating. We also discussed EXI, EXI standing for intrinsic safety. And that intrinsic safety comes by means of an IS barrier. IS standing for intrinsically safe barrier, which we commonly call the Zener barrier. Okay, those who are working on board tankers will know immediately what these Zener barriers are. Okay, so such equipment can be rated as EXIA and EXIB. Okay, where EXIA is up to 2 circuit faults it can withstand, whereas EXIB can withstand up to only 1 circuit fault. We'll go again with regard to 2 circuit faults and 1 circuit faults, okay, because this is a cross question, so you need to understand that properly. But first, let us see this particular thing. Everybody knows that a Zener barrier is nothing but a Zener diode circuit, okay? So if there is a problem, the voltage and the current are limited to a very safe value. So the voltage is limited to 30 volts DC and the current is limited to 50 milliamps. Okay. How is the voltage limited to 30 volts DC? It is based on the working voltage of your Zener 1 and Zener 2. Working voltage would mean that at a particular voltage, and that is 30 volts, the Zener diode would break down. And the thing is, when your voltage is increasing, your Zener diode is still reverse biased, but once it reaches its working voltage, is going to break down. And when it breaks down, it has the tendency, or it has the property of clamping that voltage to 30 volts DC, as you can see over here. Okay, once you have reached 30 volts DC, no matter what the voltage has gone up over here, the voltage is going to be clamped across this circuit to the working voltage of that Zen. And therefore, that same voltage will be available in the hazardous region. Also, the current is limited. How? By these current limiting resistors. And if it exceeds that, despite these current limiting resistors, then you have the fuse that is going to be. Okay. Having seen that, the 2-fault and 3-fault, EXIA and EXIB. EXIA rated equipment can be put in areas where EXIB also can be put. It is a higher safety category. EXIB cannot be put in an area where EXIA rated equipment are required. Okay. So what is EXIA? EXIA is having 2 or can have up to 2 circuit faults. What are these 2 faults? The 2 faults is, and looking back at this particular diagram over here, okay, if the current increases or if the voltage increases, that can be controlled by this. Remember, the voltage is controlled by the Zener breaking down. Breaking down does not mean going kaput over here. Zeners are made to break down. And when the normal conditions are restored, then it retains its original properties, goes reverse bias. Okay, so voltage is controlled this way. Your current limiting resistors control your current, and finally the fuse. So that is one particular fault. The second fault can be, and this is the case only when there are 2 or more Zeners in the circuit. If one Zener goes, then the other Zener acts as the backup and the rest of the things continue to work. Okay, the current limiting resistors, your particular fuse. So that is why EXIA would mean a minimum of 2 Zener diodes. Okay, with one Zener diode acting as a backup for the other. Any one of these can go, and then you have the other Zener that is going to take it up. Whereas EXIB will have only one particular Zener diode. Okay, only one particular Zener diode. Remember, whenever you're going to be drawing that, don't forget to put the earthing. Okay, and here you will be having a resistor. Okay, and here you'll be having a fuse. Okay, so either this fault where voltage and current can be limited, or this fault. Okay, if this goes, your Zener barrier is gone. If your fuse blows, that circuit is gone. So only one fault it can handle. Okay, so that is the difference between EXIA and EXIB. Okay, the safety factor 1.5, I told you, in case of any of these faults occurring, whether it is an EXIA or EXIB, then the energy that is going to be dissipated is not more than 2/3. So you divide 3 by 2 and you get this figure, the safety factor of 1.5. Okay. So this we had completed yesterday. I hope you had taken all the screenshots. I think you did. So let us see now a video on this intrinsic safety or the EXIA stroke EXIB.
Safety is one of the safest ways to ensure that an electrical device installed in a hazardous location cannot result in a fire or an explosion. It's important to understand what intrinsic safety is and how it is achieved. In this animation, we're going to focus on the basic principles of intrinsic safety, the three components of an intrinsic safety system, how the components connect and work together to become an intrinsically safe system. To demonstrate why it is critical that electrical equipment be protected in a hazardous location, let's look at the installation of an electrical circuit in such an area without any protection. An electrical sensor is placed in a hazardous location. Power is fed to it from a safe area, outside the hazardous location. If a fault happens within the safe area, a voltage of 250 volts, or even higher can enter the hazardous area. Furthermore, if a fault happens within our electrical sensor located inside the hazardous area, a high-value short-circuit current can flow into the hazardous location from our power supply. In both of these fault conditions, excess temperature, arcs, and sparks can ignite the explosive atmosphere present. Intrinsic safety is a highly effective protection technique, based on the principle of limiting the thermal and electric energy within the equipment and its interconnecting wiring. An intrinsic safety system involves three main components. An intrinsically safe field device. A safety barrier, the energy limiting device. Intrinsically safe field wiring which connects the barrier to the field device. Intrinsic safety is a system concept, and it is necessary to consider the safety of each component of the system. The safety barrier limits the maximum amount of voltage, current and power transferring to the field device to safe levels. Under normal operation, the barrier is not needed as a safety device. The input voltage and current from the power source, for example, may be transferred directly to the field device without any changes. If a fault happens on the controller, on the other hand, and 250 volts is delivered to the input terminals of our safety barrier, the output voltage remains the same as the maximum allowable value, in our case is 24 volts for example. Similarly, if a fault happens within our field device located inside the hazardous area, the safety barrier limits this faulted current to the allowable maximum level that can flow into the hazardous location from our controller. It may be clear to you from these graphics that the safety barrier and the field device must be compatible. Entity concept is a globally recognized method that specifies the maximum energy a given safety barrier can ever deliver. The same method specifies the maximum energy a given field device can ever receive and still be safe. For the safety barrier, the maximum allowable values apply to the maximum amount of voltage, current and power the safety barrier can deliver to a hazardous area, as well as the maximum permitted capacitance and inductance that may be safely connected to the output of the safety barrier. For the field device, the entity parameters relate to the maximum allowable amount of voltage, current and power which may be received as an input, as well as the equivalent internal capacitance and inductance. The voltage output of the safety barrier must be less than the voltage of the field device. The same relationship is true for current and power. The maximum equivalent internal capacitance of the intrinsically safe device must be less than the maximum allowed capacitance of the barrier. The same is true of the inductance value. Because the field wiring cables have capacitance and inductance values, these values must also be taken into account. The total capacitance of the intrinsic safety system is therefore the capacitance of the field device plus the capacitance of the cables. This total must be less than the maximum permitted value of the barrier. Similarly, the total inductance of the system must be less than the inductance of the safety barrier. Let's look at a design that is being considered. Test your understanding of the intrinsic safety system concept. Would this system be safe? Why or why not? This system includes an intrinsically safe field device with the following listed entity parameters. The input voltage is 30 volts, and the input current of the field device is 110 milliamps. Maximum internal capacitance is 20 nanofarads, and the maximum internal inductance is 5 microhenries. The safety barrier has the following entity parameters: output voltage 24 volts, output current 125 milliamps. The maximum allowable capacitance is 100 nanofarads, and the maximum allowable inductance is 35 microhenries. 20 meters of cables connect the safety barrier to the field device. Would this system be safe? As we can see, the maximum output voltage of the barrier is less than the maximum allowed input voltage of the IS device. This is safe. The maximum output current of the barrier is higher than the maximum permitted input current of the field device. Therefore, the use of this barrier is not safe in combination with this device. We need to choose a barrier with less output current. If we choose a barrier with an output current of 100 milliamps, for instance, this aspect of the intrinsic safety system is now safe. But we still need to consider the capacitance and inductance values. The maximum equivalent capacitance of the intrinsically safe device is less than the maximum permitted capacitance that can be connected to the barrier. Also, the maximum equivalent inductance of the IS device is less than maximum permitted inductance that can be connected to the barrier. But what about the connecting cables? If we consider 200 picofarads per meter for the capacitance of the cable, and 1 microhenry per meter for the inductance value of the cable, then the installation is safe with 20 meters connecting cables. The wiring connection can be longer as long as the total inductance and capacitance of the cables and the intrinsically safe device are less than the permitted values of the barrier. In summary, intrinsic safety is an inexpensive, flexible protection method, suitable for low-voltage scenarios such as instruments and sensors. It is practical for handheld devices. It is often used in combination with other protection techniques. The intrinsically safe device needs its own certification, and the safety barrier also needs its own certification. We should remember that a barrier cannot be used to make an uncertified device safe in a hazardous area. Installation of an intrinsically safe system to connect a safety barrier to a field device requires a precise assessment. The code of practice for such installations must be strictly adhered to in order to ensure that the installation is safe. Again, intrinsically safe is a system concept, and it is necessary to consider the safety of each component of the system in the loop. We hope you enjoyed this presentation.
Okay, so that's how those temperature sensors that are going to be inserted inside your cargo oil tank will be having EXIA rated for that particular sensor, okay, because it is right there in the middle of everything. EXIB cannot be inserted in these particular areas, okay. Any equipment that are EXIB rated cannot be inserted into your cargo oil tank, where you're going to be having that hazardous gas 24/7, 365 days of the year, until and unless you go for dry dock. Okay. So everybody clear? EXD, EXI, and EXIA and EXIB. Any queries or doubts? Right, so let's move on to the others now. EXE. EXE means increased safety. Please take a screenshot of this. So EXE rated equipment or EXE rating is given to electrical equipment And those equipment that can produce sparks. Okay, and what are the equipment that can produce sparks? Your switches, on-off switches, commutators, slip rings, relays. Okay, all these things make and break contact. Your commutators and slip rings with your brushes and all that, they are not making contact properly 100% of the time. If they were making 100% contact, then obviously you're not going to be having any sparks. Okay. Such equipment is given an increased safety rating, EXE, because then they are constructed in such a way that better insulation is used. Okay, and the better insulation would be probably class F or greater. Generally, it is class F over here. Okay. Also, creepage distances are increased. What is this creepage distance? Creepage distance, now just forget about anything else, even in your normal engine room, whenever you are going to be overhauling your motor, okay, you will be having your particular terminal over here inside that motor, this thing, junction box, which is connected on the motor side. And you'll have your 3 phases like this. And then there is a separator in between, isn't it? That is that creepage distance. Why? Is because even for 440 volts, if this thing was not there, then the equivalent distance between both these may be less than 0.7 meters, as we saw, that air gap, phase-to-phase air gap. And therefore, arcing might occur over here. And by putting this particular thing in between, okay, by putting this thing in between, you are increasing the distance. How? Like this. Okay, you increase, it has to go right across on top and then back to this. So just this small division over there is going to increase that creepage distance. In other words, phase to phase clearance. If this is not there, then obviously the distance has to be increased further, like this. You can see from here to here, it is not that close. But from here to here, these two terminals have been spaced out. Okay, the distance in air, as you can see over here. Okay, phase to phase distance. Also, ingress protection is given. Okay, everybody knows what is ingress protection. Ingress protection is given the prefix IP, I standing for ingress, P standing for protection. And then it is generally followed by 2 numbers. Okay, let's have a very quick look at that. Just a moment. Okay, so here's your ingress protection chart over here. As I said, you will be having this particular thing, IP, standing for ingress protection, and you will have ingress protection against solid on the left-hand side and liquids on your right-hand side. Okay, so obviously, if both those numbers following the letters IP are 0, that means it is not protected against either solids or liquids from entry. If the first figure is, let me zoom in over here. Okay. If the first figure is 1, then you can see it is protected against solid objects greater than 50 mm. Okay. And if the second figure is 1, then it is protected against vertically dripping water. That means the water is falling at 90 degrees onto that particular equipment. If the first figure is 2, then it is protected against solid objects greater than 12.5. So 2 is a better figure than 1. Here it is 50. Here it is only 12.5. If the second figure is 2, then it is protected against dripping water, but up to 15 degrees. That means 15 degrees from the vertical. If you're going to draw a flat surface like that and draw a line down, then 15 degrees from that flat surface, or rather from the 90 degrees angle. Okay, let me draw it out over here so that I don't know whether I can use this for drawing. No, like 1 second. Let me use this. Right, so let's talk about if this is the surface. Okay, this is at 90 degrees. Okay, and that is with regard to this one. But now number 2 would mean 15 degrees from here. Okay, so 15 degrees. Okay, so water that is going to be falling would be at 15 degrees angle. Okay, that is 2. Number 3, you can see that the thing has now become 2.5 mm. That means very small items only can get in. Okay, the solid objects. Whereas 3, here now it is again spraying water. Point number 4. Or figure number 4, solids 1 mm, and if the second figure is 4, then protected against splashing water all around, that is 360 degrees. Okay. If the first figure is 5, then it is protected against certain amounts of dust. So as the figure is increasing, the protection is increasing further. And if the second digit is 5, then it is protected against jetting water. You have the crew always hosing down using your fire hydrants and all that. Okay. Your fire hydrants and your fire hoses. So that is jetting water. If the first digit is 6, then no dust can also enter. This would be the best protection with regard to solids entering. If the second digit is 6, then it is against powerfully jetting water. Now, just to give you a thing from jetting water and powerfully jetting water, this is quite powerful. But if you're going to be talking about powerfully jetting water, try your Greco machine, no? The one which they are using for cleaning stains and all that. Okay, you cannot even put your hand over there because your hand can get cut by the powerful jet of water. Okay, so that is the power difference between 6 and 7. This nothing is going to happen to you. But this certainly, if you come into that particular jet thing, yes, it can cut your hand in half. It's so powerful. Okay. And if dust cannot get in, then nothing else can get in over here. So therefore, it terminates, the first figure terminates at 6, whereas you have in the liquid 7 and 8. So what is 7? Where you can temporarily immerse. Not that you can immerse it and keep it over there. Temporarily immerse. And then temporarily immerse it in what depth of water. So that also will be indicated. Up to what depth. And 8, you can continuously immerse it in that particular liquid. But then again, the depth of that liquid is going to be specified. Okay, because as you go deeper and deeper, then the pressure increases. Okay, so then you can definitely have problems in case there is any seepage. So depth also will be indicated over here with the figure 8. Okay, that is what is your ingress protection. Right? So that is what is your EXE, increased safety, by giving these clearances, giving this ingress protection so that no sparks can get out into the particular hazardous region. We'll take all these three together. You can take a screenshot of this. EXN, EXM, EXP. EXN, we saw EXE. Those are the equipment that are going to be producing sparks. EXN are given to equipment that don't produce sparks. Okay, and also the surface temperature is such that it will not ignite the hazardous gas that is surrounding that equipment. Okay, so it will be in the vicinity of T5 or something like that, where the surface temperature is kept quite low, so that is not going to be causing that particular temperature, the surface temperature, to ignite the gas, the hazardous gas, the flammable gas that is surrounding that motor. So it will be probably T5, T6 region. Okay. Encapsulation, that is EXM, where resins are used, resins, wax, whatever you want to call it. Okay, so what exactly is this encapsulation? Now, I had spoken about those temperature sensors that are going to be placed inside your cargo oil tank to measure the temperature of the oil, because some oil cargos are heated. Okay, those temperature sensors come out on deck. Let's bring up that part over. Okay, just give me a moment. Just give me a moment while I find that. Okay. So you can see this. Let me zoom in a bit. Okay, this is part and parcel of your tank radar level system. And we spoke about the TGU, TG, etc. But you can see that the temperature sensors are not fitted through this. They are separate. So your temperature sensors are going through this particular thing down into the tank. So all the electrical connections are coming up into a PCB that is located within this. Okay, now this is not gas tight. This particular fitting is not gas tight. And therefore, whatever the PCB, whatever the connections that are coming into this particular covering or protection over here, is then going to be filled with organic resins or a gel or a wax, so that in case there is a fault, no spark or arcing or anything like that is created, and therefore will not ignite the hazardous gas that is surrounding that particular equipment or even may have got inside that particular. Okay. So in case you are going to have to change, especially tanker guys, if you have to change any of these sensors, you will have to scrape away that particular resin. Okay. And therefore, when you put a new sensor, always see that that particular resin is refilled so that that area is going to be once again blocked or covered with that resin or gel or wax. Okay. EXP, pressurized equipment. Now, people working on tankers, all the three oil, gas, chemical tankers, everybody would have noticed that when we are in port, loading or discharging, the particular accommodation is kept pressurized. Okay, the chief officer goes around sending his men to close all the vents, isn't it? Whatever the vents that are there, only certain vents are kept open. That of your AC is kept open. Because you have to have an intake in the AC. It should not be fully open. It should be only crack open. Okay. All other vents are shut. And of course, excepting for the battery locker. That vent has to be kept open whether you're loading or discharging. That is the only vent that is kept fully open. Okay, so I said your accommodation gets pressurized during your loading and discharging operation. Why is accommodation kept pressurized? Can anybody give a reason?
Because the gases are outside and
Taken from
pressure
fumes.
taking from outside the intake.
Okay, yeah. So suppose this is your A deck. Okay, we are talking about normally on the A deck, because all other entry points and exit points are shut. Entry into the ship is through your A deck, either on the starboard side or the port side, depending on which side you are loading or discharging. If you're loading, discharging on the port side, then the A deck, starboard side door is kept open. In between on the A deck, you have like an airlock. Okay. So you go open this door and then you open the outside door and get out or get in. So whichever side, let's say you're loading, discharging on the port side, so you are going to exit and enter from your starboard side. So first you open, let's say you're exiting. First you open this and then you shut this door and then you open this. You will find that this particular door, if this one is not shut, this outermost watertight door is going to fly open. Why? Is because this is high pressure area and this is low pressure area. Or let's put it as LP. So as we have heard earlier and we have studied earlier, everything moves from high to low to equalize, isn't it? And in doing so, by keeping your accommodation pressure high, all these gases that are there, because pressure is moving from this side to thing, nothing is going to come over here then. And that would include your gas also is prevented from entering into the accommodation. Because your accommodation is supposed to be one of those areas which are not hazardous or a non-hazardous area. And how many things you're having over here that are non-intrinsically safe, non-explosion proof? Your chargers are there, people are smoking in their smoke rooms, even though it is in the designated area. You're lighting cigarettes, you're smoking over there. Okay. So basically, your accommodation needs to be non-hazardous in nature. And therefore, you're pressurizing your particular accommodation for that reason. Okay. Now coming to the equipment that may be pressurized. Same reason is to prevent the flammable gas, the hazardous gas, from entering into that particular equipment. So these particular equipment that are located in the hazardous region can be pressurized in a similar manner, either with complete dry air, or mostly you will be finding inert gas that is pumped in. Okay. So inert gas, of course, even if something comes inside that particular equipment, then the inert gas is going to inhibit any ignition, isn't it? Clean dry air, yes, you are going to have O2 in that. So in case there's any leakage of gas coming in, but always this is going to be at a higher pressure. So whether clean dry air or inert gas, if it is kept at a higher pressure, it will prevent that hazardous or flammable gas from entering into that particular equipment. So obviously, if a equipment is going to be pressurized, then there has to be something that is going to be monitoring. Remember when we did high voltage SF6 circuit breakers and high voltage vacuum circuit breakers, the SF6 circuit breaker, there had to be a monitor. Because if you're going to have pressurized equipment, you must know at any given instant whether the pressure is being maintained in that equipment or not. Okay, so such equipment would be fitted with a pressure monitor so as to give any alarm as the pressure is now decreasing. So do something, and then it becomes below a certain level, just like in your SF6 circuit breaker, it would trip that particular equipment. Okay. Finally, EXS. Oh, sorry, there are two more before that. EXQ, please take a screenshot of this. EXQ, EXO, and EXS. EXO is sand fill protection. Okay, you've seen sand filled fuses. And those sand fill fuses are made deliberately like that, so that because if they're going to be having a high intensity thing, if that fuse blows, then that fuse would be blown into smithereens. Okay, so they have deliberately filled in sand so that in case that fuse blows, you can hardly make out that it has blown. Okay, so likewise here also, you can have, instead of EXM resin or wax, you can have sand fill, which is going to be doing exactly the same thing. It is going to prevent that hazardous atmosphere from creating a particular explosion in case there is some fault and a spark or something like that is issued. Okay. EXO is oil immersed. Oil immersed is rarely used on board ship for the same reasons why we saw oil circuit breakers are not used for your high voltage. Okay, they don't dissipate the heat very easily. Okay, but otherwise the oil is going to be used to cool that particular thing in case there is any fault and a spark or something is issued. Okay, and it is also going to quench that arc of spark that is issued, because that particular equipment is immersed in oil. Okay, and as you can see over here, oil should not get overheated so as to catch fire. So very rarely you will find this oil immerse protection on board. Last but not least, EXS. This means a special protection where it has not been ratified as yet. They are all available in the market and they have to prove themselves in the market. That is called special protection and is given the suffix EXS. Okay, let me show you an example of EXS. Okay, just give me a moment. Just a moment, guys. I think it should be in this one. Okay, I won't be showing you the video.
Okay. You can at least verify
Okay, so this is the thing over here. Okay, I'll play it from here.
pictures, I should say, on some of them. We also have motors and things like that. Now, new ideas.
Okay, so here he's terming it as new ideas. That means they are already manufacturing certain things which is going to prevent a fire and explosion. Okay.
This is something that I came across about 2 years ago. There's a manufacturer, Stahl, that is creating a EXD enclosure that is, I think, 60% or so lighter than a traditional EXD box. It actually has a pressure relief. So we'll show a quick little video. This is second to last slide. And then we'll open it up to questions for everybody. So it's a good video to show that when there's an explosion inside, that heat, pressure, particulate matter is stopped. The particulate, the matter is stopped by that mesh screen, and those screens cool down and slow down that explosive pressure. So it's, sorry, 50% lighter than a traditional box. It's been approved by 2 ATEX notified bodies, 30 patents going on. So just wanted to give people that an idea that there is new ideas.
Okay. So that's what it means. New ideas which have not yet been cleared, so to speak, for use, or at least on board the ship. Okay. And that would be given this particular thing called EXS, Special Protection. Okay. We've taken a screenshot of this and any queries or doubts thus far. So these are the 9 means of explosion proof rating. Okay. Right. So finally is this particular question that is asked in the orals. So you can take a screenshot of this. Flame proof or pressurized lighting system inside the pump room. So if you're talking about a pump room, that means it is either a chemical tanker or a oil tanker. Remember, gas tankers don't have pump rooms. They have what is called as a compressor room. Okay. And the question that is asked with regard to your pump room lighting is that the lighting has 2 particular this thing. Okay. So let's say, let me go down a wee bit. Okay, so you're having one set of lights here. And you're going to be having another set of lights. Okay. So you're going to have 2 sets of lights in your pump room, such that if you want to, this one has gone kaput, for example. So you would need to isolate the power to this. You don't need to isolate the power to this because this is on a separate circuit. So you will have light in the pump rooms sufficient enough to work on this particular thing. You cannot work in total darkness. Okay, so what is the question? Tanker pump rooms require 2 separate lights of separate lighting system, 1 and 2. How can circuits so be arranged that the lighting can only be opened up when the correct circuit has been isolated? So we said, okay, so now we need to isolate this one because this one is gone. We keep this one off. How can the thing be so arranged that only the one that needs to be isolated, you can then open up and work on this? Okay, remember, as I said, when we were talking about the battery locker, that light in the battery locker, we said there is one end where there is a cap that is screwed inside. And as I said, to prevent that particular cap from getting loose, there is a metal strip, and then there is a Allen key-like structure, isn't it? That is going to hold that particular strip in place and prevent this particular cap from getting loose. And as I said, you will be having either this, there are various shapes, okay? You have hexagonal, okay? The keys for this are released only, suppose you're having this particular key for this set of lights. The key that is then going to open any one of these light fittings is released only when this breaker is switched off. Okay. Likewise, if the key of this one is this, for this side, okay, if you have to open up any one of these lights and the key for that is this one, then until and unless you switch off the breaker, then the key for that is going to be released and you can work. So that is what they are meaning over here. How can circuits be so arranged so that the lighting can only be opened up when the correct circuit has been isolated? That is what is meant. So when you switch off the breaker, the key for that circuit, for that particular light fitting will be released so that you can then very safely open up that particular light fitting, carry out the repairs, put everything back to normal, return the key back to that particular breaker and then switch on that breaker. Okay. So now everybody knows, at least those who have had experience on board tankers, these keys, you will not find this. Okay, first and foremost, those keys are either in your possession as an ETO or it is kept in the cargo control room. Okay. You can go and do it whenever you want and you do the normal isolation. It is not having this interlock. Why this question is asked? Because of DT Hall. Gentlemen, so I suggest that if you don't have it till now, please get a soft copy at least of DT Hall and go through. Several questions that are there are asked in the orals on various subjects. So whilst this is not practically so on board the ship, since it is appearing in DT Hall, you have to give that answer and not exactly what is on board your ship. Okay? Because they are only going by this answer and this answer only. Is everybody clear with regard to this lighting? Any queries or doubts? Any queries or doubts on this entire chapter of special electrical fittings on board oil, gas, and chemical tankers?
Clear, sir.
Excuse me, sir.
Yeah, go ahead.
Sir, in my container ship that we have in DG cargo holds, we have this limit switch operated lights. That one comes under which category, sir?
Limit switch operated lights in which particular area is this?
It is a DG cargo holding cargo holds. Sir.
DG means what? Dangerous cargo?
Yes, sir. DG dangerous cargo.
Okay, so really speaking, if you're carrying dangerous cargo in your containers, then your container is capable of keeping that dangerous cargo within its limits. Okay, it is not going to think. So having a limit switch over there, it is not going to come in any particular category as such. Where exactly are the lights located?
Inside the cargo hold. Cargo hold, sir.
Inside the cargo hold.
Yes.
Okay. So if that cargo hold is having limit switches, okay, for the lights, those lights will be coming on only when that particular container might be removed from that area, or if in the other case, when the container is within that. Okay, I have not been on a container vessel, so I cannot even imagine what exactly that is. Okay, so if you have some photograph or something like that, if you can share it on the group, then possibly I can make an explanation with regard. But other than that,
Okay, sir.
I don't see any particular protection as such. Okay, because the protection will be given and done by the container itself.
Okay, sir.
Excuse me, sir.
Yeah, go ahead.
In month of the November, survey asked me the question, what are the fittings you have seen in the pump room? So what I supposed to answer, and I have answered that electrical fittings are like emergency explosion proof lights and fire sensors and all. So what are actually supposed to I supposed to answer?
Yeah, okay. What are the equipments that are there in the pump room, right?
No, he said what you have seen electrical fittings in the pump room.
Okay. What are the electrical fittings? Yes, very correct. You'll have your explosion proof rated light fittings. If there are switches, those switches will be outside of this thing, but inside the pump room, apart from those light fittings, you're going to be having your sensors, isn't it? Such as your level sensors or floats over there. Okay, then with regard to, in fact, most of the things other than electrical, your light fittings, most of the things are all pneumatic and other operating. But any sensors that are going to be coming over there, okay, that is going to be intrinsic, your explosion proof rated. Very few sensors, really speaking, because what is going to be done is the air is going to be taken, for example, to sense all your gases, any gas that might be there, that is going to be drawn into your particular fixed gas detection system that is going to be located in the safe area, not in the hazardous area. So apart from your light fittings, there is nothing much you're going to be thinking. Your phones over there, you have a phone in the thing, that is also going to be a special, the sound phone that is there. The lights, the horn, the alarm for your gas detection, the alarm for your fire thing. Those are not strictly speaking electrical. They are going to be air operated and the solenoid will be outside. Okay, but the lights over there, whatever the lights are, for your fire thing, it will be one particular light. For your gas detection, it will be another light. Okay, these are electrical fittings. Okay, your sound powered phone per se is not electrical. That is why it's called sound powered. It is not electrical powered like your normal phones are in your cabins. But certainly those other light fittings that I just now mentioned that are going to be indicating what the alarm is, that is electrical fitting. So yes, they also have to be specific with regard to your explosion proof rating. Other than that, I don't think there are any other electrical equipment in your pump room. You have to limit the electrical fittings within the pump room because that is part and parcel of your zone 0, isn't it? Okay, so very few electrical fittings will be found in your pump room.
And so what about the sensors, the level sensor and COPT sensors and all?
Your COPT sensors are all pneumatic, this thing. They are not electrical sensors.
The
Okay?
temperature sensors and also
Huh?
COPT temperature sensors and all.
That is, again, your temperature things are all located in your engine room, no? It is just a thing that is there alongside that. The temperature is only because of a temperature bulb that is kept over there. So that is going to be sent to that particular meter which is inside your engine room, isn't it? Next to your COPs, those temperature gauges which are over there.
Yes, sir.
Okay, it is not an electrical thing that is being fitted over there next to your pump bearings. Okay.
Yes, sir.
Right. Any other queries or doubts you have on this particular chapter before we move on? Okay, so our next topic is the emergency generator. Okay, so emergency, by the very name emergency, means that one of your generators that was running has packed up for whatever reason and you are having a blackout. Okay, so this generator, again, the all important Solar's chapter 2-1 part D. Okay, and the regulations 42, 43, 44. 42 will be with regard to passenger vessels. 43 with regard to cargo vessels. And 44 with regard to the starting of your emergency generator, starting requirements, etc. Okay, you can go through this. I'm pretty certain most of you all will be having your soft copies of your solars. Okay, please go through this. And as I said, please make certain that solars chapter 2-1 part D, you know it like the back of your hand so that you can quote at any given time. Okay. So this particular generator, when you're going to be having a blackout, it is supposed to start and come on load within 45 seconds. Okay. Start plus come on load within 45 seconds. Within, not at 45 seconds. Within 45 seconds. So on some ships, maybe on your ship, maybe within 30 seconds, your generator started and come on load. Some will be on 35 seconds. Most of the ships I've sailed on, we were having 35 seconds. So it does not mean to say that when you're having this particular regulation, that at the 45th second, you can start a come load. That is the end. That is the limit which Solas is saying. Okay. And this emergency generator is not that powerful. It will be only for essential or emergency equipment, primarily with regard to the safety of the vessel. So one of the very first things that comes to mind with regard to the safety of the vessel, your vessel is going through narrow waters, okay, ships left, right, and center. And let's say you have a blackout, unfortunate incident, and you have a blackout over there. At least you can steer the vessel safely till power is restored, because you need the thrust from your main engine so that you can steer. But as long as you can steer away from trouble. And your emergency generator will be giving your supply to your steering gear motor number 2. Okay, generally it is given to steering motor number 1, number 2 rather than number 1. For what reason, I'm not sure, but they've always selected your steering gear motor number 2. They could have very easily given it to steering gear motor number 1. No issues. Okay, but it's always given to steering gear motor number 2 in this case. What are the other equipment that are going to be powered? Motors, your main air compressor number 2. Okay, your emergency fire pump, all your emergency lighting, your navigational lights, your GMDSS equipment, at least one radar. Generally, it will be the X band, not the S band. The X band, why? Is because you will be able to locate SARTs. X band radars are the only radars that can spot the SART signal. Okay. Right. So, emergency generator that can start and come and load within 45 seconds, SOLAS chapter 2-1, part D, in one of these regulations, and regulation number 44, you will find them. Okay. So in this particular SOLAS chapter 2-1, part D, just one moment, let me allow you to take a screenshot. Just a moment, let me readjust. Yeah, you can take a screenshot of this.
Sir, regulation number 43 for the is passenger ship, right, sir?
43 is for cargo vessels.
And 42 is for the passenger.
Yeah, 42 is for passengers. Just one moment. Let me get that also.
Sir, one day we will try out this average generator test.
Hmm.
And actually we did this many times, but like when we cut from the ECR, so the breaker of this cut off and the generator was started. This was happening all time. But the one day what happened when we trying this out, we press the off the ACB in the ECR, but the ACB in the ECB panel, it doesn't got off. So what could be the reason for this one, sir? Later I have to put it off manually.
Okay, so that means the under voltage strip for that ACB was not working then. You should have an under voltage strip coil for that
Yes,
ACB, no?
yes, sir. It was there. So that could be the malfunctioning.
Yes, that could be malfunctioning. That is why it did not switch off.
And we have, and you will be very surprised to know this. We had very worst condition for the one ACB in the ECB panel. Someone, I mean, we have many ETOs on passenger ships. So one of we don't know who. Before us, one guy put the spoon inside the breaker.
For what?
To keep it hold all time.
My God.
And we were very disturbed why this not happening. When we opened this ACB, we found one spoon inside.
Shucks.
Yeah.
What an irresponsible guy that is. Just give me a moment whilst I get this thing. 1 minute. Only when you want to find the SOLAS, you can't find. 1 minute, huh? Okay.
Is it possible to have the soft copy of these all regulations?
Which regulations you're talking about?
Like we are getting the on a screenshot. So it is possible to get some PDF file for us.
I don't have PDF file. You will have to somehow the other memorize what are the regulations. So we are talking about 42, 43, 44. Okay, and in this case, here is SOLAS chapter 2-1 part D. And 42, as you can see, with regard to passenger vessels. Okay, so one cannot reproduce everything in my notes. Therefore, I precede my notes. 43 is with regards to, 42-1 is with regard to ro-ro vessels. 43, as you can see, is with regard to normal cargo vessels, tankers, bulk carriers, container vessels. Okay. and 44. Okay, starting arrangements. Okay, a lot of cross questions. So, for example, you should be able to easily start your emergency generator even if it is freezing temperature of 0 degrees centigrade. Okay, so what I have given over here are some pertinent points, not all of them. So you'll have to go through 42, 43, 44 to know all the various points because they have been asked in the orals. Okay, one of which is your emergency generator shall start and come on load upon the failure of the main supply within 45 seconds. Within, not at 45 seconds. Number 2, emergency generator shall be located above the uppermost continuous deck. So, when you're talking about uppermost continuous deck, this is your clue. So, suppose this is your ship. Okay, and here's your accommodation. And here's your funnel deck. Okay, which is the uppermost continuous deck that you will first come across? Continuous. I gave
First
you.
deck, sir.
Sorry,
First deck.
which deck?
First deck, sir. First deck. Just above the upper deck.
No,
The one on which we can go from forward to after the ship. That deck.
exactly. So that's why I put this in inverted commas. No, upper deck. Whenever you climb onto the ship from the gangway or exit the gangway, you go onto this deck, isn't it? It goes right from forward to aft, as you very rightly said. Okay, it shall be located above that deck. So it can be on A deck, it can be on B deck, it can be on C deck, D deck, depending on how many decks you have. It can be any of those decks, apart from your bridge deck. Why it's not put on the bridge deck? For certain reason, it might interfere with the bridge and navigational equipment. Okay. Even if it is located in your funnel deck, then you'll have a small thing. Normally, it is located on the port side. You'll have a small stair going up by about a meter, meter and a half, and then you'll have the emergency generator. Why do you think it is not on the uppermost continuous deck? Any reason that you can think of? So sometimes some examiners like to be a little bit, they like to finger in between. Not that it's going to be mattering much, because if you have answered yes, it can be on the above the uppermost continuous deck. That's what SOLA says, and that's it. But sometimes they like to finger and say, why can't it be on the uppermost continuous deck?
So we had it on uppermost continuous deck.
Yes, even I also had it, but then you would have had problems whenever you're having any wetting inspections or anything like that.
Probably because of bad weather. Bad weather.
Yes, mainly because of bad weather. Okay, your shipping seas left, right, and center. And although the fish plate that is located here at the break of the accommodation is very high, mainly to prevent any oil or anything from coming up, but your sea water is just pouring in over there, and your accommodation side, your aft, your poop deck gets pretty badly flooded with that water, despite all your scuppers and all being removed. Okay, those plugs that are being normally put for your tankers and all, they're all being removed. Okay. And the reason why it is not there is that possibly that water can get in to your emergency generator room, either through the door or through that particular hole that is provided where you're going to be taking your show connections. Okay, so just like you said, you had it on your uppermost continuous deck. Yes, I also had one of my ships where the emergency generator was located on the uppermost continuous deck. And every time we had any inspection, whether it was PSC, whether it was USCG, whether it was AMSA, whether it was wetting inspection, they all made a remark in their book. And it was removed, okay, when we had proved that not a single drop of water could enter the emergency generator room. Very critical, this emergency generator, especially when you have lost power. Okay, if you have lost power from your main generator, very critical this becomes. Especially if you are going to be having lost power in a huge storm. You're rolling and pitching very badly. Water's gotten, and then that kills your emergency generator, then finished. Okay. So that is the reason why it is not generally found on the uppermost container. For this reason and this reason only. Okay, most of the ships will be having it slightly higher than that, and mostly you will find it in this particular area in your funnel deck, and you'll have a small stairway going up about a meter, meter and a half, and then you'll have your emergency generator. Okay. So emergency generator shall be located above the uppermost continuous deck. So really speaking, we are contravening SOLAS over here by having it on the uppermost continuous. Okay, we are contravening, and the only way that we can get out of this thing during an inspection is by having the particular emergency generator room pressure tested. You have at least 3 or 4 hoses with high pressure against that door and your entry portion for your show connection. Okay, and not even a drop of water should enter. Not even a drop. Okay. They should be also readily accessible from open deck. So let's say it is quite often you will find it either on A deck or B deck or C deck also. So you can get to it via the accommodation, or you have your companionways externally. You can climb up and get access to your particular this thing. Okay. It shall be readily accessible from the open deck. Okay, so from the open deck means you can go via the companionways that are there. It shall not be located forward of the collision bulkhead. Now, collision bulkhead is generally located over here. From the container vessels, you have a thing over here. That bulkhead goes down right over here. We don't see it on any of the other ships, tankers included. We don't see it. Okay. So nobody in their right mind will be having the emergency generator room over here, because that's where you're going to be shipping the maximum seas, isn't it? Point number 3, emergency source of power and main source of power shall be so arranged that in the case of a fire in either, it shall not affect the supply of the other. There shall be no contiguous boundaries of ER or main generator section. ER means, or rather it should be EG, not ER. Okay. So your main generators are located right down here in the engine room. By having it above the uppermost continuous deck, you are ensuring that it is not going to be having contiguous boundaries, means same boundaries as your main generator. Because we do not want the heat of one particular fire, whether it is in your emergency generator or your main generator, from affecting the other during the emergency crisis. Okay, so your main engine, main generators are located far below, and these are located far above, so that in case of a fire, the other is not affected at all. Point number 4, on passenger vessels, supply for your emergency power illumination. Okay, not just your illumination, for your entire thing should last for 36 hours. Okay, for 36 hours. Whatever the equipment, whatever the emergency lighting is going to be lasting for 36 hours, which means that the fuel in the tank for your emergency generator on board your passenger vessels should be sufficient enough to provide you minimum 36 hours. Okay. And what are the particular illuminations that is going to be supplying at muster stations, embarkation stations, exits, alleyways, your main engine side, at your generator starting positions, at your ECR main switchboard, at your ESB also, at the steering gear, because sometimes you'll have to do manual steering. When I say manual steering, emergency steering, that is. Okay, so you'll have a light over there. Your fire pump and emergency fire pump. Now there are 2 pumps, 3 fire pumps. One is a big fire pump. Okay, which if you are going to start that, then you have to start 2 generators. Then you have a smaller one called fire and bilge pump, isn't it? So that is the pump that can be operated off the emergency switchboard, and of course your emergency fire pump. Then your navigational lights, GMDSS equipment, any internal communication, that is your normal phone system, fire detection system as well. Okay, and other such equipment. As I mentioned, even your main air compressor, number 2. Point number 5, for cargo vessels, all these equipment would be powered by your emergency generator for 18 hours. Half that for your passenger vessels. The reason why passenger vessels have for 36 hours is because of the number of people on board. On board our ships, our cargo vessels, we are having a maximum of over 25, 26, 27. Worst case scenario, whenever you're carrying families, 30, 31. Okay. Compare that to your passenger vessel where you're having thousands of people on board. Okay, so some of the points are mentioned here. The other points, please go through Regulation 44, where you will see the starting things also. Okay, with regard to the oil that has to be in the sump, and then it should be capable of thing, even if the ship is rolling up to a certain degree. Okay, all that is mentioned in this. Okay, in 42, 43, 44. Okay. Right. So if you're taking a screenshot of this, first let me clear out all this mess. Okay, everybody's taking a screenshot. We can move forward. Okay, you can take a screenshot of this. We'll discuss the diagram. And this question, as you can see, what are the alternate means of starting the emergency generator? You have an emergency generator, you're going to do your Saturday routines. we start up the emergency generator in the normal way. Okay. Connect that particular battery, whichever battery is to be connected, battery 1 or battery 2. Put it in the manual position and press the start button. That's it. But other than starting it in this particular manner, what are the alternate methods that are going to be provided for starting? Number 1 is hydraulic and number 2, pneumatic, which is using air to start. We'll be seeing both these starting methods. Sometimes you have a spring start. Very rarely you'll find that, whereby you rotate till the spring becomes tighter and tighter, and then release that spring. And that spring is then going to start your emergency generator. But very rarely you will find that. These are the two most common means of alternate starting for your emergency generator. Everybody's taking a screenshot of this?
Yes, sir.
Okay. So now let us start this explanation. Now, in the orals, it is asked to draw and explain. Leave alone the writtens. If it is asked in the writtens, no problem. The time is in your hands to control. But in the orals, the time is in the examiner's hands. So you will need to draw the simplest circuit possible. You will get various circuits online. Okay. But I found, and we've been using this particular thing for ages in our institute. Can't get simpler than this. Okay. So under normal circumstances, when your main generator is supplying your main switchboard, the bus tie breaker is closed. Okay. The under voltage strip for the bus tie breaker would be energized, and thus your main generator via your main switchboard and the bus tie breaker is supplying your ESB and all the equipment associated with the ESB. Okay. Now let's say the problem with the running generator has occurred. But before that, when this bus tie breaker was closed, you can see that there is a holding on coil. The holding on coil gets energized, and when it gets energized, it's going to magnetize this soft iron core. The soft iron core will move in this direction. When it moves in this direction, as you can see, it is coupled to all these particular breakers. It keeps the starter switch in the open condition. It keeps the emergency generator ACB also open. And it keeps the ACB that is supplying your main switchboard power to your ESB. It keeps that ACB closed. Okay, this is a diagram so as to give that explanation. Otherwise, it is all logic, particular signals that are being given. Here we are showing it mechanically. Okay. And remember, as I said, in the examination, they are going to ask you with regards to basics. And this is the basics. So during your normal supply from your main switchboard to your ESB, the holding on coil gets energized, its soft magnetic core gets energized, keeping the starter circuit open, keeping your ACB of your emergency generator open, keeping the ACB that is going to be supplying your main switchboard to your ESB, keeping that closed. and power is supplied to your ESP from your MSB in this manner. Then let's say something has happened and your emergency and your main generator is tripped, which means you don't have any voltage. So the under voltage trip for your bus tie breaker will trip that. Okay. And when it's going to get tripped into the open condition, then the holding coil over here, as you can see, is now no longer energized. Okay, it's no longer energized. And therefore, this particular thing gets de-energized, the soft iron core. And when the soft iron core gets de-energized, it's no longer being pulled by this holding on coil. It is going to get released and it'll move in that direction. And when it moves in that direction, this one will close, which means your emergency generator will be started up and will be running idle. It's not yet come on load. This ACB is not yet closed because it will close only when this timer is going to count down. And a max of 45 seconds that timer can be placed. As I said, you can have it 30, 35, 36, 37, 38, 39 seconds also. But no later than 45 seconds. And of course, this one now is going to become open circuit. Okay, ensuring that despite your bus tie breaker being open, this ACB is also opened up so that's not to have any interference between your main generator and emergency generator. Should your main generator come on load at any given time. Okay, you can never have your main generator and emergency generator running parallel. Why? Is because this might be 1200 watts, kilowatts, and this is only 300 to 400 kilowatts. Okay, so the question of running parallel, remember parallel, as I said, you're going to be sharing the power equally. And remember, in your emergency generator, normally you don't have an AVR and you don't have a governor motor. Normally. Okay. So this is the condition when you are going to have your main generator tripping. This is the scenario, and then your timer counts down. Okay, whatever the timer is set at, provided it is up to 45 seconds, then at the 45th second, okay, this ACB will be closed. Your emergency generator is then supplying your emergency switchboard with the required power. And then from your emergency switchboard, you're getting all your other equipment, emergency equipment, being supplied from your emergency generator. Okay, so restoration of your normal power. Okay, the engineers for some this thing, okay. Generally speaking, if one generator trips, your first standby comes on load automatically. But let's say there was a common problem and it did not come on load. Okay, that's when your particular emergency generators has already come on load and is doing its job. Let's say whatever the problem was has been solved by the engineers and your main generator started up. So your main generator is then supplying your main switchboard. When it is supplying your main switchboard, the under voltage coil over here for your bus tie breaker will get energized and it will reclose this. Okay, it will reclose the bus tie breaker. When it recloses the bus tie breaker, okay, once again, this holding on coil is going to get energized the soft iron core is going to also get magnetized and move in that direction. When it moves in that direction, your starter supply is removed, your ACB is opened for your emergency generator, and this one is closed. And your power is restored also to your ESP. Okay? So sometimes, now this ACB open and closing is here shown as mechanically. Okay? This is for simplicity's sake, but then you will be having also a under voltage trip for this. Okay, so the under voltage trip will trip whenever your main generator is thing and it will automatically open. And when the thing is restored, then it will automatically close. But then this interlock is there. Okay, the interlock between this breaker and this breaker is there, such that when this breaker is energized, this one remains open and vice versa. So that both your main generator and emergency generator are not on load at the same time. Okay? Everybody clear thus far? Okay. So let's see these questions and answers. We said that one of the questions asked is what are the alternate means of starting? And you've told the examiner, okay, pneumatic or hydraulic. Sometimes you have the spring thing, but give only these two. If he says, what about the spring type? Then you say, yes, sir. I forgot about that. Be very, this thing, don't ruffle the feathers of this thing, okay? So, another question is asked, and this is a very pertinent question. What if hydraulic or pneumatic means is not provided? Okay, on the same ship that I was on that had its emergency generator on the uppermost container's deck, that particular emergency generator did not have pneumatic, it did not have hydraulic. Okay, what is then required if you don't have alternate means of starting? The answer is that you saw in this particular diagram, you are having a DC series motor that is going to be given supply by the starter circuit. Is this motor that turns your emergency generator and then makes it run normally. Okay, so you should have a spare series DC motor with dedicated tools. Not I will go down to the engine room and get those tools. No, the tools for removing the bolts, nut bolts of that particular DC series motor and fitting back a new one, that will be there in the emergency room, emergency generator room, together with this spares series, DC series motor. Okay? And you will require to replace, take out the old one, put the new one and fit it in place all within 10 minutes. Okay, everybody clear? Any queries or doubts? Okay, very quickly, and then tomorrow we'll be seeing the videos. Very quickly, how do you start? Listen to the question very carefully. How would you start your emergency generator? What was described over here was auto start. Now you're going to be asked by the examiner, how will you start? In other words, it would mean, how would you manually start your emergency generator? We are very familiar with that, right? All our ETOs very familiar. Even the engineers also will be very familiar with that. Because every Saturday we are doing that routine, no? We go, check the batteries, check the oil, check the radiator water, etc., etc. Then put the thing in manual and press the start button. Khatam. Your emergency generator starts. That's all. How would you start your emergency generator? That is what you're going to be telling the examiner. Okay, after doing all the mandatory checks of your battery, oil, your sump oil, your radiator water, etc., etc., we will put that particular panel into the manual mode and press the start button for that emergency generator. The emergency generator should start and remain offload. It is only going to be running idle. So that is the answer of starting your emergency generator. Starting and putting the emergency generator on load is a different matter altogether, and that's where this test switch is going to come into place. That test switch is located on your ESB, manual auto start. So when you're going to be using that switch, of course, whenever you're going to do this particular thing, you will be informing chief engineer, captain, and both of these will be in turn informing the company after doing the risk assessment. And normally you do this type of a test whenever you are at a safe anchorage. Unless regulation, especially when you're getting into American territorial waters, the 100 territorial mark, and then the local territorial water. You have to test your emergency generator twice, and that is out at sea. And then report back to the USCG that you have tested out your emergency generator as per the requirement. So that's a different case scenario. But otherwise, when you're going to be testing it on load, one would never do it out at sea because a lot of essential equipment are running. Okay. So how do you do that? You will turn that switch from your auto position to the test position. And when you turn it to the test switch position, what are you doing? You're going to be opening this particular contact, which is simulating that this coil has got de-energized and therefore will be starting up the sequence of start. Okay. And of course, at that time, when you're going to be doing that, this bus tie breaker will also be opened up automatically. Okay. Your emergency generator will start at the end of before 45 seconds. The timer will count down. Close this ACB. At the same time, opening this ACB and supplying your emergency switchboard with the 440 volts. Okay. So starting the emergency generator and starting and putting the emergency generator on load are two different things. So listen to the question very carefully whenever the examiner is asking you that question. Okay. Right. So we have two fairly longish videos, which we'll be seeing tomorrow. We'll be seeing in the first video how the equipment is started normally whenever we are doing the Saturday routine, and then when it is going to be started using the pneumatic means. Okay, that's pneumatic means air pressure that is used to start your emergency generator. The second video will be showing you the starting using the hydraulic means, the alternative means of starting using hydraulic. That means oil pressure to start. Okay, so we will see that tomorrow, both those videos, very informative, and you will know exactly with those videos how to tackle the questions that might be thrown at you by the examiner. Okay.
Excuse me, sir.
Yeah, go ahead.
Sir, एक question है sir.
Yeah, go ahead.
Sir, as an ETO, what we मतलब क्या maintenance करते हैं sir हम PCB पे?
On what?
PCB sir, printed circuit board.
On a PCB.
Yes sir.
First and foremost, isolate, clean, use a brush.
Okay, sir.
Okay, use a clean brush that too. Brush out all the dirt and dust that might have collected on the PCB. Then use your contact cleaner for your this thing and spray that. And
Okay,
then
sir.
dry it completely. That's all. Then check any of the components are loose. If any components are loose, resolder them. Okay, resolder that thing. See if there are any.
Also, we need to put the ESD band.
Sorry?
Also, we need to put on the ESD band, ecstatic
Yeah,
wristband.
that depends on if they are having any electrostatic sensitive devices. Yes, then yes, you'll have to put that band also. And earth that band as well. Okay?
Okay, sir. Thank you, sir.
You're welcome. Okay, guys, so I'll see you tomorrow again at 11 o'clock. We'll continue, finish with the two videos, very informative videos there. And then we'll move on to the next topic after this. Okay? Thank you very much for joining.
Okay, sir. Thank you. Bye.
Thank you, sir.
Welcome.